Good morning, everyone, and welcome to today's presentation on surprising combinations of research contents and contexts. We're going to explore how collaboration across distant scientific disciplines can lead to truly impactful discoveries. It's fascinating to see how bringing together different perspectives can spark innovation and breakthroughs, and I'm excited to share some insightful examples and ideas with you. Let's dive in. When we talk about surprising combinations in research, the first key idea is unexpected pairings. This means bringing together topics, methods, or contexts that are usually far apart, which helps generate new insights you wouldn't get by sticking to one discipline alone. The real innovation happens when these distant elements come into contact. The second important point is low prior relatedness. This refers to how unrelated the fields are before they combine. When fields have little overlap, the combination can spark truly original ideas because it involves transferring knowledge across very different contexts. This low relatedness is what fuels the surprise and potential breakthroughs in research. If you look at the image, it's a great metaphor. A man holding a small shark on the beach, something you wouldn't expect to encounter together. Just like these research combinations that blend seemingly unlikely elements for exciting results. When we talk about scientific outsiders, we're referring to individuals who bring fresh perspectives from outside the core field. First, they use different methods, techniques that are unique to their original disciplines, which means they often offer innovative approaches we might not have considered. Next, they ask different questions, posing inquiries that aren't typically part of the main problem domain. This can lead to entirely new avenues of investigation. Finally, they work with different data, analyzing types of information that aren't conventional within the target field. This combination of diverse methods, questions, and data often leads to breakthroughs that insiders might overlook. The image here of a microscope focusing on a leaf specimen reminds us of the detailed, yet sometimes fresh, perspectives these outsiders bring to scientific research. When we look at why distant disciplines spark innovation, the first key idea is problem reframing. By approaching problems from a completely new perspective, we can uncover solutions that wouldn't be obvious otherwise. It's about shifting our mindset to see challenges in a different light. The second important concept is method transfer. This means applying tools or techniques from one field to another, which can lead to breakthrough innovations. By borrowing methods developed elsewhere and adapting them, we create new opportunities for progress and creativity. Together, these approaches highlight how crossing boundaries between disciplines can open up exciting pathways for innovation. The light bulb image here symbolizes that moment of insight that comes from thinking differently and combining ideas in unexpected ways. Here, we're looking at empirical citation patterns that reveal an interesting trend. Papers that combine topics from distant fields tend to receive more citations than expected. This is significant because it shows that when researchers draw connections between seemingly unrelated areas, their work not only gains more attention, but also sparks new avenues of research. What's particularly striking is that the rate at which citations grow is steeper for these distant topic combinations compared to papers focused within a single discipline or closely related subjects. This highlights the unique impact and value of surprising, cross-disciplinary connections in driving innovation and advancing knowledge. Here we highlight some notable examples and breakthrough stories that demonstrate the exciting advancements in science and technology. First, bioinformatics plays a crucial role by merging computer science with genetics to analyze complex biological data. This integration has significantly propelled genomics research forward. Next, we look at neural networks in biology, where artificial intelligence is applied to understand cellular processes more deeply, opening new pathways for discoveries. Finally, the intersection of materials and design brings artistic thinking into materials science, resulting in innovative prototypes and groundbreaking solutions. The image of the laboratory scene complements these themes, showing the hands-on experimental work behind these innovations. This approach broadens the toolkit available and fosters innovative problem-solving by combining diverse methods. Finally, serendipity and networks highlight the power of chance encounters and connections. These unexpected meetings often spark new ideas and valuable partnerships that might not have happened otherwise. Together, These mechanisms create a fertile environment for outsider contributions to thrive. When we look at the barriers faced by scientific outsiders, two key issues stand out. First is gatekeeping. Established fields often impose restrictions that limit access and participation by those outside their immediate circles. This creates a significant hurdle for new voices trying to contribute to the field. The second major barrier is evaluation bias. Both publication and funding processes tend to favor insiders, making it even more challenging for outsiders to gain recognition and support. This bias, combined with additional hurdles like translation costs, further complicates the pathway for those trying to break into established scientific communities. The image of the microscope here reminds us of the different lenses through which science is viewed, yet not everyone is given equal opportunity to use them. Here we're looking at key opportunities and institutional supports that can really drive innovation. First, funding and incentives play a crucial role. By providing cross-disciplinary grants, we encourage researchers from different fields to come together and create innovative solutions. Next, collaborative spaces like design labs are essential. These spaces are designed to be modular and flexible, making it easier for teams from various disciplines to work together seamlessly. And finally, training and exchange programs help develop the skills needed to translate knowledge across fields. This kind of skill building is vital for effective collaboration and idea sharing. Altogether, these supports create an environment where interdisciplinary work can thrive. When we talk about measuring the impact of cross-disciplinary work, it's important to recognize some limitations of traditional metrics. Conventional measures like citation counts often miss the subtle and unexpected connections that interdisciplinary research creates. They don't fully capture the broader influence that this kind of work can have beyond just academic citations. On the other hand, assessing emerging topics by tracking how new ideas develop and lead to downstream applications gives us valuable insight into their real-world significance. This approach helps us understand how these innovations evolve and gain traction across different fields, reflecting their true impact in practical terms. The image here illustrates this with data from Google Analytics, showing how user engagement and demographic information can provide a dynamic view of influence over time. Here we see how integrating computer vision into ecological monitoring has transformed the field. Traditionally, monitoring species was challenging due to low detection rates and the heavy labor involved in manual observation. By bringing in computer vision techniques, we automated species identification, making it not only more accurate, but also much more efficient. As a result, detection rates have improved significantly, giving us deeper insights into species behavior and overall ecosystem health. The comparison chart clearly highlights how automated methods outperform traditional manual approaches in accuracy, marking a real breakthrough in ecological research. The image of the human and robotic hand shaking perfectly symbolizes this powerful collaboration between humans and technology. Here we focus on the future directions for interdisciplinary science, highlighting three key strategies. First, integrative training programs are essential. By developing cross-disciplinary workshops, we can nurture diverse expertise and build strong collaborative skills among researchers. This creates a foundation for innovative problem-solving. Next, flexible funding mechanisms play a crucial role. We need adaptable grant structures that encourage unconventional and creative research combinations, allowing scientists to explore new ideas without traditional constraints. Finally, shared platforms for data and tools are vital for collaboration. Establishing cloud-based environments enables resource sharing and joint analysis, making it easier for teams across disciplines to work together effectively. These approaches collectively pave the way for more dynamic and impactful interdisciplinary research. Here's a summary of the key insights we've discussed. First, what they are. These surprising combinations involve novel pairings that spark innovation by connecting ideas or fields that might not typically intersect. Next, why they matter. They contribute significantly to breakthrough outcomes, with about 50% impact on discovery, 30% on methods, and 20% on practical applications. Moving on to key barriers. Common obstacles like lack of funding, limited collaborative spaces, and inadequate training can hold back progress. Finally, to address these challenges, there are specific actions to take. Providing dedicated funding, creating collaborative spaces, and offering specialized training programs. Each of these steps plays a crucial role in fostering innovation and overcoming the hurdles we face. Thank you for staying engaged throughout this presentation. Now we'd like to invite your questions and insights. We encourage you to think about how these ideas might apply in different contexts and share your perspective. To help guide our conversation, consider these discussion starters. Which outsider-led method do you think could be most helpful in your work? What kind of institutional change would most encourage surprising and innovative combinations? And finally, how might you adapt these concepts to address the unique challenges you face? We look forward to a lively and thoughtful discussion.